Hey guys, in today's video I'm going to be showing you how to set up pathfinding for a 2D game, so without further ado, let's jump right into this video. Now, I did recently do a video on how to do this for a 3D game, and if you want to check that video out, I'll leave a link somewhere on screen. But to do this in 2D, we want to actually start by adding a level. So in this case, I just added a 2D scene, which is a node 2D, and I renamed it to level 1. As a child of the level 1, I'm adding a navigation 2D node, and as a child of the navigation 2D node, I'm going to go ahead and add a tile map. Then, with the tile map still selected, I want to go over to the inspector, and then I want to do tileset, empty, new tileset once more, and I can actually add a tileset now by clicking the plus sign here, or I can simply click and drag a tileset into the area as shown there. Anyway, I'm going to be using my square.png as my tile, and I'm going to be using a new single tile, and then I'm just simply defining the region for my tile. Now in the inspector, you want to make sure that you actually set the snap options for the step to be the size of your tile. So in this case, my tile has a size of 32 by 32, so you want to set the step to match that. Anyway, since I want to use this tile for navigation, I want to make sure that I don't actually define a collision for it. All I want to define is a navigation shape. So go ahead and define the shape for your navigation for this tile, and you want to make sure that it actually covers the entire tile, and now we can actually click and draw our level. But as you can see, it's actually the wrong size, so to fix this, we want to go over to the inspector. Under the cell options, we want to set the size here to match the size of our tile. So in this case, my tile has a size of 32 by 32, so that's why I set it to a size of 32 by 32 for the cell. And now I can actually draw my level without having any issues. Now, the areas where we're drawing the tile with the navigation are the areas that the enemy will actually be able to move and walk on. So just go ahead and create a level now, and when you do, you're pretty much set. So I actually went ahead and created a level beforehand. As you can see, in this case it's just a normal node, which I renamed to world, and as you can see, it also just has a navigation 2D as a child, and which also contains a tile map as a child of it. In this case, the tile map, which the first tile is the blue, is my navigation tile, which is, like I said, going to be the area my enemy will be able to walk on. The turquoise colored tile is my walls, which actually have collision, and then the third tile, which is the dark blue tile that's going around my walls, is a tile without collision or navigation, and the reason I did that is so that my enemies don't actually get stuck or too close to the walls. Anyway, let's actually make our enemies now. So I actually went ahead and created my enemy beforehand as well, and it's just a kinematic body 2D with a sprite, which is the same square.png texture as earlier, and then I just set the self-modulate to a red color, as you can see here when I hide the collision shape. And then for the collision shape, it's just a rectangle shape, and I basically just resized it by using the handles on the viewport as you see here. Anyway, that's pretty much the setup for my enemy. Now let's actually add a script to it so that we can actually have it make use of the navigation. So go ahead and add a script. In this case, I'm just calling it enemy, saved in a folder called enemy. And in this script, we want to start by defining some variables. In this case, I'm going to define an export var for the speed. And in this case, since it's 2D and not 3D, we're working with pixels. So we're going to set the speed to 100. And then var velocity is going to be equal to vector 2.0, and then it's going to be var path is equal to an empty array, and then var threshold is going to be equal to 16, and then var nav is equal to null for now. So it's basically going to be the same code we use for my 3D example of pathfinding, but I do have to adjust it to work with 2D, but it's going to be pretty similar. And we're actually going to get the nav in a different way from my 3D example. So in this case, we're going to get it by doing func ready, and inside this function we want to do yield owner, and we're waiting for the owner to be ready, and when the owner is ready, we're just going to do nav is equal to owner.nav. In this case, the owner is going to be the world. Anyway, after that, we want to do func physics process delta, and inside this function we want to do if path.size is greater than 0, we want to do move to target, which is a function we're going to make right now. So func move to target is simply going to do if global position dot distance to path and then square bracket 0, so the first index of my path array, is less than the threshold, I want to do path.remove index 0. Else, I'm gonna do var direction is equal to global position, which is my current position, dot direction to path square brackets 0. So the direction 2 basically just returns a normalized vector pointing from this vector to B, and it basically just gets the direction to the point that we define. In this case, it's going to be the path at index 0. Anyway, underneath that line of code, we want to do velocity is equal to direction times speed, and then velocity is equal to move and slide velocity, and we're doing that so that our enemy actually moves. Anyway, we actually want to get our path as well, so we're going to define a function for that. So func get target path, and it's going to take a target position or target pos as a parameter. So inside this function, we're going to do path is equal to nav.getSimplePath, and for the get simple path, we want to do global position and then our target pos, and then we're going to set false. So if we actually search for get simple path, as you can see, it basically just returns the path between two given points, which is my start point and my end point, and then optimize is by default set to true. I'm setting it to false because I noticed that if it's set to true, it kind of gets stuck on the wall more, so I'm just setting it to false so that it basically, kind of fixes that issue a little bit. Anyway, I'm actually going to add my enemies to my world scene here. And I actually have a node that I made beforehand to act as a container for my enemies. So if I run the scene now, it will actually crash the game. And the reason behind that is because my owner.nav is actually not defined yet. So like I said, the owner in this case is the world. So to fix that issue, we want to actually add a script to my world. So I just called it world.gd. And then all we want to do here is we want to get a reference to the player and to the navigation 2D. So onReadyVarPlayer is equal to $player, and then onReadyVarNav is equal to the navigation 2D. As you can see, if we run the game, it won't actually crash now, but the enemies aren't moving, and that's because we're actually still not calling the getTargetPath function in our enemy script. So we need to actually call this function somewhere. And in this case, I'm actually going to call it by using a group. So for my enemy, I'm going to go over to node groups and add it to an enemy group as shown here. Now, over in my world, I want to go ahead and actually start by adding a timer. And this timer is going to be what's going to actually call that function on our enemy. So we're actually going to go to the inspector with the timer still selected, and we want to make sure that it's set to auto start, and then the wait time of 1 is fine. And then we want to go over to node signals and then connect a timeout signal to the world. And inside this function is where we want to call the getTargetPath function on our enemy. So we want to do getTree.callGroup, and we're calling the enemy group what method we're calling. So we're going to call the getTargetPath method on our enemy, and then we're passing the player.globalPosition as the parameter to the getTargetPath method on our enemy. And as you can see, the enemies are actually now chasing the player and moving towards the player. So everything seems to actually work properly. And if I move around, as you can see, they will continue to actually follow my player around. And like I said, the dark blue tiles are there just so that the enemies don't get too close to the walls, therefore getting stuck on the walls. You can do it in a different way if you don't want, or you could honestly probably disable the collisions as well and work with the collision layers if you want. I just did it this way as a quick fix to that. Anyway, I'll be leaving a link to the GitHub project in the description. If you liked the video, make sure you leave a like and consider subscribing as we're on our way to 1,000 subs. Also, if you're interested in online multiplayer using Godot, then consider following my Kickstarter project, which would be a course on online multiplayer using Godot. So if that's something you're interested in, then definitely go check it out, as whether I make the course or not depends on how much interest I see people have in said course. Anyway, I'll see you guys in the next one.